This is our hardware-in-the-loop test setup. On the left-hand side, we can see WisentWire. It is connected to the power supply on the right, to the programmer that's connected underneath the shelf, and also the DUT at the bottom. The DUT is a basic sumo robot. It can also communicate with WisentWire via UART. Lastly, on the input GPIOs of the WisentWire, we have the wall that's visible on the right-hand side. It is used to detect if the robot is able to stop before it or ends up hitting it. All of the available WisentWires are visible in the dashboard. We'll use TS02. To start off, we will reserve this WisentWire. We can do this with a calendar and add a simple description of what we're doing. Now we have to select the WisentWire TS02, hit save, and WisentWire is reserved. It changes red so that people in the office know it's reserved, as well as it becomes reserved on the GUI. We can control the power supply from our WisentWire, set different voltages and currents, power it on. We can see the device turned on as we get a DUT1 ready. We can select a frame of communication that we use. It's a custom DUT1 motor control protocol frame we've defined ourselves. We can send a ping command to confirm if the device responds. As we can see, we got a Pong response. So now we can set the speed to 80 and run our robot. It should stop before hitting the wall. We can observe this on the GPIO telemetry. When calling forward, we should expect N0 to drop low, as that means that the sensor has detected a wall. However, N1 should still stay high, as we do not hit the wall. We can now flash the device with broken firmware, one that will not detect the wall. In this scenario, the device should end up running into the wall. And then we should see N1 go low. As you can see, our device was flashed. It responded again with DUT1 ready. So we'll go through the same procedure of setting the speed to 80 and calling forward. After calling forward, you can see that we hit the wall. This is visible on the GPIO telemetry. We'll now call stop. We can also investigate on the power supply how things were going throughout the test. We can see that during movement, we were around 200 milliamps. At the end of using our device, we should free it, and it's good to go to be used by others. All the features that we presented now through the GUI are also available through our API, SDK, and MCP server, so you can do everything you saw from the comfort of your terminal or AI agent. We also recommend checking out our videos concerning coding with our MCP.